All right, we're going to talk about input-output. And to do that, I want to kind of walk through a program. We're going to do some stuff here and talk about what this program does and why. And then we're going to actually take a look at the code and start building the code. But I'm not going to do that on this board. So, first of all, I want to talk about what the problem is. And in genetics, you have a particular coding. And we're actually going to be working with some genetics data. And you could have something like ACT. And a mutation might be something like this A turning into a TCT. That would be a single letter mutation. Now each set of these things, 3 long, produces one protein. Actually not an entire protein. It produces one amino acid that goes into building a protein. So a big long sequence of these 3 longs produces a protein. And some single letter mutations are actually quite deadly. In particular, I'm thinking about things like Hodgkin's lymphoma and cystic fibrosis. There are 300 and some single letter mutation diseases. Cystic fibrosis is probably the most famous of those. It is a single letter mutation. So if you just have one letter out of 2 billion wrong in your genetic code, you get this deadly disease, if it is in the right location. Now, about 20 years ago, we had the Human Genome Project. Out of the human genome, they sequenced a bunch of people. They found out where this was. They isolated the protein and what happened with this protein. And then they used some machine learning and some artificial intelligence to come up with a set of different possible drugs. And out of that set of possible different drugs, one of them was actually tested and is now sold under the brand name of, and I'm going to mispronounce this, Trikafta, Trikafta. And Trikafta will cure this disease. It doesn't cure it, it treats the disease. You have to have it every week. And it actually isn't too expensive. I think it costs around $50 for a prescription per week. So, not cheap, but not hugely expensive. And it is available these days to treat people. Now, the detail on Trikafta is, although it is very effective, if you don't have this mutation, it will kill you. So you have to get genetically tested. And you have to verify that you do have this mutation. And somebody that is sick, like Steffi, would like to not be sick. They'd like to actually have this, know if they have the mutation, get tested, get this figured out, So what I want to do is give you a little bit more than the genetic description of this. And this is kind of abstract. We've got a file, it's got a bunch of letters. We're going to go read the file, we're going to search through it, we're going to find out, yes, if the pattern with the mutation appears or doesn't, so that Steffi can get treated. Now, Steffi has a YouTube channel, and I actually have a clip of her next talking about this disease, and then we're going to walk through the details of what it looks like. Now, in your homework exercise, there is a big long string. There's 2 of them. And the first one is what you're looking for, which I don't know if you can deal with this. Somewhere in there is a single letter mutation. And the second one is what a person is supposed to have instead. So, now remember that what I said is a human genome is 2 billion long. Not everything inside the human genome encodes proteins. There are starts and stops. We haven't talked about that. It isn't relevant to this. And I'm not giving you a 2 billion long file to go search through. I'm giving you a little piece of it. So up at the top of the homework exercise, there's the link to download this particular piece. I will also send out that link in email and put it in the lecture information for this. I didn't put this up on WildWeb because the file's pretty big. Even a little piece of it is pretty big. So you get to download it from the same place you would where I'm putting movies and videos for this class. And that way it isn't a problem. Now, when you get done running it, it's going to end up in your downloads directory. You need to move it to where your program is so that it can find it. The next lecture, we go through a bunch of Unix commands, a bunch of command line commands, and how you do it. That's not the only way to move a file, but you're going to have to move it to there. And I would probably do this homework exercise, get it done, get it turned in, and then when you get done with it, delete the file. Because it's big enough, you probably don't want to leave that laying around on your computer. It's going to take up a bunch of space. All right, let's go look at the two videos and let's learn something about this disease, cystic fibrosis, and see what the motivation is for finding out whether Steffi has it or Steffi doesn't. And let's take a quick look at that and see what this drug does for her.
Disabled. I struggled to climb stairs, I struggled to talk. Some days I could barely even walk because I would struggle to breathe so bad, and I would just go into coughing fits. Once your lung function gets down into like the 30s, that's about the time where doctors start talking about lung transplant, which is something that I never really wanted to do, because even if I did get a lung transplant, I would still have cystic fibrosis, and eventually those lungs would become just as damaged as my current lungs. And also there's a big risk with transplants that eventually the lungs will reject because they're not your lungs and your body doesn't know what they are. It's a foreign object. I knew that at the rate my lungs were declining, that I only had a few years left to live, and because CF is progressive, each year was getting harder and harder.
All right, well, I'm going to give it away. Okay, this is likely to be her genetic code, and I'm giving you a piece of it. And we're going to go in and see if it has this pattern in it. I actually edited it. This is what the contents of the file looks like, and I went down 30,000 lines in it. That's not any particular location, but 30,000 lines. Now, let's see what effect this Trykovka jug actually has on her.
I have so much more energy than I've ever had, ever, and I'm so excited and like happy. Ready? Wait, listen to this. And I didn't even cough.
Okay, now what I want to do is I want to open a file, and I've just called this sample.txt. I'll build a sample.txt here in a second. Take that file and set it up so that I can read from it one line at a time, because genetic files are big enough that you don't want to read the whole file into memory and then process it. Your computer will probably just crash and say, meh, can't do it. And then do some kind of processing on the file. So the first thing I've done is I've set up a file name. Now this is a sample. This isn't the real data. The reason for that is I want to test what I'm building first. So I'm going to do with open as FP so that I get the file, and I'm going to tell FP that the process I want to do is the read line process. Read line is going to do one line at a time, and so I can sit here and loop through the lines one at a time. And I'm going to use a while loop, and the way that we might use a while loop is to say, start off with a thing at the top where we're going to get the line number. That's one of the pieces of information I want. Go through and process it, and then do line number equals line number plus 1. So I'm going to get the line, process it, and I'm going to keep doing this. And each time I go through this loop, I'm going to move to the next line down. Now let's run this. Remember, I have to create SAMP as well. Okay, let's go back to this, and I hope I named the files the same. And let's run it once, and yes, it says line 1, ABC, 2, DEF, 3, GHI. So this looks like it works. Now, I see some things in here I don't like, and I'm going to fix those on the next sample, which is going to be, I would like to start off and move this line number equals line number plus 1 up to the top of the loop, because it's much less likely, at least for me, that if I do something like that, I put it at the top, I don't forget it. Otherwise, half the time I forget to put it in. So we'll move it to the top. And let's build out sample 2. So let's go over here and click on the little plus thing. And I'm going to take sample 1, read it in, and we'll build out sample 2. So go back here, and we'll just take this and we'll cut and paste it. And I'm going to make some improvements. That's all we're going to do. Okay, so if we're going to move the increment up to the top, I actually have to start at 0. And then we're going to do line no equals line no plus 1. This will make it a little bit better. We'll take that out. It should still work the same way, so if I run it, I should see the same output. Okay. All right, and it works. I saw the same output. Now, what we'd really like to do is we'd like to change this processing in here to do something more useful. And what we want to do is we want to look for the pattern in the file, which means I'm going to need to change the file, and I'm going to look for a pattern. Now, the way I would do that is I would come up here and I would say the pattern equals DEF, so that I've got some test data for that pattern. And then inside here, instead of printing this out, we'll say if line, and I can't say equals here because that would be the whole line. What I need to do is I need to look inside the line and pick out one specific thing. Now, one way we can do this is there are functions that are associated with lines. So we do line.find, and we want to look for pattern. I called it pat. And we want to say if it is not equal to, which is an exclamation equals -1. Now, what find does is it looks in one string for another. Now, as soon as I've done this, I'm going to want to print out that I found it. And I think we want to do found at line. So we do found at line and we print out the line number. Now, like our testing code, if we want to be able to print out a message at the bottom that says that we didn't find it, then we're going to need to add another variable up here. We're going to need to do something like found equals false. Notice that there's a capital F on false there. And when we find it, we want to say that we found it. And also, if we find it, we no longer need to look through the rest of the file. So, and not found. Then at the end of this, if we have not found it, I have changed something. Notice that's underlined in red. That's because we should have a lowercase f there. If it's not found, we'll just print out a message that we did not find it. Now, hopefully with DEF, we'll be able to find it. So let's try it inside sample 2 here. And I did something wrong. I believe I left off some parentheses, maybe. Okay. It's good for you to see that I make syntax errors too. Okay. I think that is what I did. Okay. So we go through and we print out the lines, and we found it at line 2. We never went on to line 3 because it found it and it exited the loop. So basically, this is what you want to do, except you want to replace these things with the actual things. You want to use the real file once you get it tested, and you want to use the real pattern once you get it tested. But this is basically what the code needs to do.